Good morning everyone and good afternoon sir. Today we are happy to present our lab 10 for the subject BITI1113 AI. In this lab, we will talk about machine learning. We will show you 3 real-life examples of 3 main types of machine learning. The first one is supervised learning, and the second is unsupervised learning, and the last one reinforcement learning. We'll explain how a spam filter uses supervised learning, how recommendation system like Spotify or Shopee use unsupervised learning, and how a robot vacuum uses reinforcement learning to clean the house. We want to show that machine learning is not just theory, it's used in our daily life. Before we start, let me introduce our group member. First, YUEN, Yeap, Xiang, Xiang, and KANG. Okay, let's begin with our overall presentation.
My name is Xiang. Today I will explain supervised learning using a spam filter as an example. A spam filter is used in email system to detect whether an email is spam or not spam. The input data is a collection of emails. These emails are already labeled by humans as spam or not spam. For example, email with paid promotion or unknown sender may be labeled as spam, while normal email from school, work, or friends are labeled as not spam. The system is trying to learn the difference between spam email and normal email. It looks at patterns such as keyword, sender address, link, and email content. This is supervised learning because the system learns from label data. The correct answers are already provided during training. After training from many examples, the spam filter can predict whether a new email should go to the inbox or the spam folder. So supervised learning means the machine learns with guidance from label example. Here is an example of a spam email in my email account. For supervised learning, the system is trained using many emails that are already labeled as spam or not spam. The input data include the email content, sender address, and keyword. The system learns the pattern of spam emails such as paid promotion, unknown sender, or dangerous link. After learning from label example, the spam filter can predict whether a new email should go to the inbox or spam folder. This is supervised learning because the system learns from label data with correct answer. Thank you.
So I'm the third member of this group. I'm Xiang, and then my part is the unsupervised. So let's moving to the example 2 for unsupervised learning. We have the music or shopping recommendation system. So let's look at the input data. In this system, the input data consists of user behavior. This will include the history of song listened to, item, view, clicks, likes, and post-purchase history. Next, what it learns. The system analyzes this data to find similar user or similar items. Based on these hidden groups, it then automatically suggests new music or products to the users. Finally, why this type? Why does it belongs to unsupervised learning? Because it is in this example, no fixed label are given, so the system is not trained on correct answers. Instead, it discovers patterns by itself, purely based on user habits. So to summarize it up, the keyword at here is pattern without labels. So this is my part. Okay, thank you.
Hi, so I'm Yeap from this group, and now I'm going to present the third learning, which is reinforcement learning. Now let's look at our example, reinforcement learning in a robot object. First, for the input data, the robot continuously collects real-time data from its environment through sensors. This includes its current spatial position, detect or tasker objects like walls or table legs, the location, battery level, and the set of possible movement it can execute. Second, what is the system trying to learn? The goal here is to learn an optical navigation policy. In other words, it is trying to find the most efficient training path while dynamically avoiding bumping into objects. Finally, why does it belong to reinforcement learning? Unlike supervised learning, there is no fixed data set here. The core mechanism is a loop of reward and penalty. The robot learns entirely by interacting with its environment through trial and error. When it gains efficiency, it receives a possible reward, but when it messes up, when the walking robot messes up, like crashing into a tablet, it receives a negative penalty. Through thousands of trials, the system automatically optimizes its choice to maximize reward, teaching itself how to master the room layout. Thank you.